It's boot camp time. Okay, so today we're going to talk about quadratics and finish quadratics next class. So, if you have any questions over quadratics, watch this video. Question number 1. Which statement about the quadratic parent function is true? A couple of things we need to know about the quadratic parent function. A quadratic parent function is y equals x squared. That means the vertex is 0, 0 because it will always pass through 0, 0. That is the quadratic parent function. And if the vertex is 0, 0, I am telling you the axis of symmetry is x equals 0 because it's the first number of the vertex. So the parabola will be cut in half using the y-axis. Even though that's x equals 0, that's still the y-axis. It also means that the minimum or the maximum will be 0. So y will equal 0 for the min or the max. Now, how do we know which one we have? The a in this problem is 1. Since he is positive, our graph is going to point up. So when a is positive, the graph points up. That means I have a minimum. If a was negative, my graph would point down. That would mean I would have a maximum. So now, what are the points? Well, and let me write minimum right here. If 0 is plugged into the x and I square it, I get y is 0. That's how you get 0, 0. But if it's 1, plug in 1. 1 squared, that's 1 times 1 would be 1. And if it is 1 away here, and this is the middle of the axis of symmetry, it needs to be 1 away here. Then we plug in 2. So 2 squared is 2 times 2, not because of him. I'm not saying 2 times this 2. I'm saying 2 squared means take 2 bases, 2, and multiply them twice because there is an exponent of 2. Just like 3 squared would mean take 2 bases and multiply them twice because it says an exponent of 2. Hopefully that made sense. So 2 times 2 would be 4. 1, 2, 3, 4. And then 3 would be 9. 3 times 3, 9. So 4, 5, 6, 7, 8, 9. Okay, and if I am 2 away this way, I need to be 2 away that way. And another way to check that this is correct, if I take negative 2 and plug it in here, negative 2 squared would be negative 2 times negative 2. Negative times a negative is a positive. 2 times 2 is 4. So it is 4. And then last but not least would be 9. If I'm 3 away, I'm going to be 3 away as well. And negative 3 times negative 3 is positive 9. So now we have our parabola, and it is not a V. I like to call it a U with open arms. Okay, so this is my parabola. Okay, the next thing, let's talk about the domain and the range. Domain refers to vertical lines. So, how many vertical lines touch this graph? This one touches it, that one does, and that one does. But does this one here touch it? And a lot of people say no because they forget to hit the arrow. Well, remember that line keeps going, and so it will eventually touch it. Even if I put this pencil way over here, this vertical line is actually going to touch that graph eventually because it's going to keep going. You see the lines, they're beginning to intersect there. So yes, it will touch it. And even on this side, the same thing. It will eventually touch it. So all of them touch it. That means the domain is going to always be for the parent function and any quadratic function, all real numbers. And this is the way you will see it on the test. So this is the domain. All real numbers. This is the domain. The range is going to be horizontal lines, which look like this. And horizontal lines on the graph touch the graph starting at 0, but not these. So there are no negatives. The positive y values touch the graph. So this is positive. And not only do the positive values touch the graph, but how do you represent that? Since it is pointing up, it's greater than or equal to, and you start at the min or max, and here we have a min, so and it's 0, so greater than or equal to 0. And this is always the range for the parent function. So y is greater than or equal to 0 is the same thing as saying non-negative numbers or positive numbers. So that is the range. And as you can see, it says which statement is true. Well, these are false because they're backwards. That's the range, and that's the domain. The domain is not the non-negative numbers. The domain is the set of all real numbers. So they did those backwards. The range was the non-negative, not all real numbers. So those aren't true. Be careful here. We know that this is x equals 0, and we know that he is y equals 0. But it says the x-axis and the y-axis, not x equals 0 and y equals 0. So what cuts it in half? That's what it means by symmetrical. Which axis cuts it in half? And this is the axis of symmetry, so the y-axis cuts it in half. Which graph below appears to have only one 0? Okay, well, the first thing we need to do is write down everything we know about zeros. I am a 0 if wherever it crosses the x-axis, it goes in the x spot, and then the other side of my ordered pair, meaning the y value, is 0. Now, it does not include changing it. That is incorrect. Only the y, the y can be, I don't want to say only the y because sometimes it goes through 0, 0. So let's just say whenever the y equals 0, you have a 0. Whenever the y equals 0, you also have a solution. Whenever the y is 0, you also have an x-intercept. You also have roots. In other words, wherever the graph crosses the x-axis, you have y equals 0, a 0. That is the most important thing. Where the graph crosses the x-axis is a 0. That's when y equals 0. So how many of where the graph crosses the x-axis does it want? How many zeros does it want? Only one. Okay, well, does it cross the x-axis here? No, it doesn't touch it at all. So this is what you call, I have solutions, they're just not real. And you learn about what the solutions look like for this when you get to Algebra 2. But you need to know that that is no real solution. Or no real solutions. And then here, I guess I can put the S back. How many solutions do you have here? Well, it doesn't touch the x-axis at all, so again, no real solutions. Okay? So it can't be this one. And then here it touches the x-axis twice, so this would be 2 real solutions. Because you can actually see where it crosses. And then here, it has 1 real solution. So A would be the answer. What else do you need to know about these problems, these answer choices? It has one real solution. This is also called a double root. And it's called a double root because the x value repeats, like twins. Okay? So one real solution, and it's repeating. So it's called a double root. What else do we need to know? Let's find the domain and range of each one. What's the domain always going to be, no matter what the problem looks like, if it's quadratic? You should have said all real numbers. Now on the STAAR test, I don't believe they're going to put the symbol, but to know the symbol now, put you ahead for Algebra 2. You will see the word set of all real numbers. Now the range is a little different. If it's pointing up, you're going to use greater than or equal to. If it's pointing down, you're going to use less than or equal to. So on this one, what's the range? Well, it's pointing up, so y is greater than or equal to what? And so find the minimum, and that is 1, 2, 3, 4. So greater than or equal to 4. Now we switch it up, and on this one, is it pointing up? No, it's pointing down. So the range is going to be y is less than or equal to -1. Less than because it's pointing down, and it starts at -1. Then we do this one, and it's here at -1, but it's pointing up, so the range would be greater than or equal to -1. Again, when you point up, it's greater. When you point down, it's less than or equal to. Okay, so I'm going to stop the video now, and then on the next video, we will do the solution set question.